Hey, hello guys. Thanks for joining on this second part of the reversing basic training that we are giving this month. Uh, so on the last one, last week, we we were halfway on the DragonCrack. I don't know if anyone has finished it yet. Otherwise, we're gonna give some time on that one. Also, we will go through it as well. Maybe we can get deeper into some other cool stuff we can do. But for warming up, I should send you guys on the chat. You can get it there. Let me also get it actually. So we can do some warm-up exercise. It should be quite easy to solve. So of course, as last time, there you go. As the last time, you will need a debugger, of course, of your choice. So you can follow along what I'm gonna do here. I haven't seen this fragment, but I believe that is also a basic one. Should be able to which is fine. If you have any question for that, just let me know, please. Chat here. There you go. All right. So how do we start with this one? So first, put it in somewhere so you can identify it. You can put it in Jadra, you can put it in the Detected Easy, or choose run file into it if you are on a Linux box. So it's 32 weeks compiled with MintGW. I hope it runs fine. Now we can drop it here into IDA. There you go. Let's also open it on Jydra. I got the latest version of Jydra recently. It's not it's the latest stable one, but there are of course newer versions that you can get directly from their Git. There is basically, if you get the latest version of it from the Git, you also you will also have here in your tool chest, besides the code browser, there is only one more. There is called debugger, and as the name implies, you can also debug with Jydra. That's quite cool. So let's open it with Jydra as well, so we're gonna see difference. All right. Okay. Let's put it here. So basically, Jydra and IDA, they are quite similar, as you can see here. Well, in IDA, what I have here is the main on the main screen on the IDA view is a graphical interpretation of it, and here I'm directly seeing the text of it. So if I want to have exactly the same one, then I can just go ahead and open the graph view, the function graph, sorry. Then, well, if I go somewhere, oh, good. God bless you, man. Let me. I hope it's not Corona. What you have? All right. So yeah. So let's try to do the same here. So go through. So on Jydra, if you double click on this guy, then what's going to happen is it's going to take you there. Yeah. Lower the volume. Okay. So well, take you here. So you have true and fail. Of course, please go ahead. Please feel free to go ahead and start to. Yeah, you can try to solve it. What I browse into it. you should be able to solve it quite quick. So you have a true, fail. Well, there is a way. Yeah, here is asking for the password. I think this is in French. Right. Anyway, it will take you there, and again, you have the cross references, and you can choose double click into the reference. And as you can see, well, I'm here under this reference, and if I want to if I want to scroll it, I have to press Shift and then I scroll it there like that, or I can move on the map. So yeah, so I can see. I think I can select it here, and then if I want to do the same in IDA. So let's do exactly the same. So first we need the string windows, and then we actually click it on true, and then we follow the reference from here. So we have this reference. We can drop the reference with X, or we can choose, like with Jira, we can just double click on the reference, and then it will take you there. So let's do basically the same on both. And I'm insisting on this because, well, as you guys know, IDA is a paid product and Jira is open source one. So, well, it's free. So, but you better learn to use the free one, because it's also quite a good alternative to IDA. As you can see here on the right side of the screen, we have the decompiler of it. As you can see, I have some comments that I added to here, like if already showing me the value of the true variable for the offset that correspond to this one, and here is as well. You can do the same, I believe, you can do the same, exactly the same here, I believe, in Jira. This can move it as well, and you can rearrange it. But in any case, we know that this is the one that is gonna go to true, and this is gonna be the fail one, right? Yeah. So if we follow along with this, yes. Show it here. So if we follow along with this one, then what's going to happen is we can change the color, and well, it's already we want it. And then let's do the same here. So like that, and then put it in green, and this guy is going to be. As you can see, there are some like really minor differences between these buggers. For instance, for quality of life type of features, Jira is smart enough to just save the colors that I typically use. For instance, I always use these two, like green, and I use it on a different project, so it's already saving it there. So my preference on this one, I have to do it. It's already like showing. It's already this is already linked, like showing me where it goes. For instance, if I select this print, then it's gonna show me where it's sitting in the disassembly part of it. If I select here, it's showing me here this scanf in the pseudocode. If I go back here into IDA, it's not doing it by default. But what we need to do is well, first you need to have X-rays as well, and then you have to put it in a different window, and then in order these two to be synchronized, because if I'm doing this, nothing happens. What I need to do is to select this view and then right-click and synchronize it with pseudocode. Well, you might have more windows to select here, but at the moment I have only two that can be synchronized together. So now these two are synchronized, so you need to select the proper one, and you can have multiple pseudocode windows and multiple IDA views, X view, etc. So as it is right now, it's doing exactly the same. If you don't like the interface, for instance, say, hey, I just really don't like this letter, I would like to have it how IDA looks, you can do it, or the other way around. You say, I would like IDA to be like more like Jira, then you can do that as well, of course. You can rearrange the windows, like for instance, if I want to have exactly the same type, for instance, the graphical view, I have it here, here I have it here, you can move it around, of course. that's not a problem. Also, I noticed that the pseudocode that Shydra spit out when you when you call the compilation part of it, it's easier to read. I think it's more accurate if actually if we compare it. You see, for instance, it's easier to read, right? That's what it looks more like real code. This is not the best example because the code is quite really small, but I noticed that the code from Java is easier to read and it's more accurate. It's a more accurate representation of what the code should looks like, and you can make your own checks because you can have your own code and then decompile it and then you can check it. So first you make a binary, you have the source code of the binary and you can decompile it. That's compare it with the source code itself. Also something really cool that you can do with debuggers, you can import the symbols and you can, instead of having a decompilation interpretation of the code that how it should looks like in the view of X-rays or Jydra, you can also import the symbols and then just have the real source code so you can compare. That's a really nice comparison you can do. You can synchronize the pseudocode with the real code, and then you can just bring one line by line and how it should look like. Because that's a reality. The Shydra, the compilation part is, I think, is better for me. There is and other people think the same. There is this plugin that you can use in IDA to have the decompiler instead of having the X-rays. You can have the one from China. And also something cool about that is that the decompiler, of IDA, of course, is paid. You have to pay it separately. The one from China is free. So if you have IDA Pro but you don't have X-ray, you can use the decompiler from China. Alrighty, so moving along, let's try to solve this guy. So I'm gonna run it. So let's see what happens. So it's like that. Then it says fail. So let's go ahead and put a breakpoint somewhere. As you can see here, it's just this call. Oh, well, of course, this will start here supporting main. And here you can see, remember from the last week I showed the libraries that you have here. There are the libraries and the functions that I used. It only use like kernel32, MSB, CRT, and then for the exports, it's only main. And yeah, and you can follow along here, and it's gonna call here, and then it's gonna go to the main, to the real main. There you go. So, and if you want to go back on what we were doing, you can just press ESC, and then we are back to start. That is here, and of course on IDA is basically exactly the same. So exports, and then you go there, and then you can just go like that, and then we arrive on the same place. So let's do it together. So here, then boom, then we are on the same page, yeah. And then we need to go to the main function that is this guy, and then from here, like that, then we arrive on this main. Oh, this I don't think this is the correct one. I think I click on the. All right, this main, and then and this is the main. All right. Okay, so basically we did the same on both. So there you go, and the other one is here. Okay, I cannot run it on I cannot run it on Jydra. If you want to run it on Jydra, then you have to go to Jydra Git. That's their GitHub, and then you need to clone this repository, and you will have the debugger. And if you want to learn how the debugger works, it's basically the same as IDA. Of course, it has a different view, and then they did something really cool about it, about the debugger and everything related to Jira. Is that the documentation of Jira is really quite good. So if you go to, I think they have it here. Yeah, somewhere it was, well, a few versions ago it was directly listed here, but it's not the installation guide, it's the manual. Oh, sorry, my PM is restarting. Yeah, the manual of I think you can access directly from the tool itself. Let's open it up. The manual from Jira is quite good. The manual for IDA is also really good, but I think more people were we are working on the manual of Jira. The thing about IDA is it has been there for long, so that's why they are in books. I share the PDF with you guys. That if you like it, you should buy the physical book. Let's open this again. Sorry for that. And we need to open this guy again. Close. All right, so we said we wanted to check out the help contents. There you go. Yeah. So yeah, this was the manual. So and it's also online. It's exactly the same manual. So as you can see, it's quite good. I mean, and it's all there. And it has the screenshots and everything, so it will take you wherever you need it, and it has a search function as well. So if you are doing something like I don't know how to set a breakpoint, then you can choose look for it, and then it will show you how to set well, not for breakpoints actually. That's a bad example because that's part of the debugger. It's a really bad example, but yeah, you know what I mean. And something really interesting about Jira as well is that you have all these scripts that you can use. You can create your own with a script manager. For instance, the analysis that we run at the beginnings, they are listed here, somewhere here. Yeah. So yeah, and of course it supports Python as I showed there, and you can call the interpreter here. Well, that's setting. Of course, it's the Python interpreter for Jira, and it's a Jython base. Because of that, because Jira is using Java. Basically, you can write your scripts you can automate everything and write your own scripts using Java, or you can just use Python, and it's gonna be interpreted by Jython. That is a Java interpreter of Python. And same scenario for IDA, but instead you have Python or IDC. For instance, if I want to make something out of it, I can choose write a dictionary breakpoint, and then for instance I can select the language here. In this case, well, I can use Python or IDC, and then just type your script there. And there is also there are also plugins that you can write your own plugin and import your plugin as well. There are really cool plugins, and there are some really good ones for exploit development that I might show you on a different training when we cover the exploit development training. But all right, let's get to it. So let's remove this breakpoint. Let's put this guy here, and let's set it up. Sorry, something I forgot to mention. There is something really cool about this. On the last version of IDA, I think it was on colors, right? Yes, you can change the interface and make it look like more hackerish, like that, or completely dark. But to be honest, I don't like it. I prefer I prefer more like easier to read colors. Okay, so let's put a breakpoint there, and then I'm gonna minimize this. I'm gonna continue execution. I'm gonna go until the scanf. There you go. There. So now we should type some. And then basically what we can track is where our password is gonna go. So now it's doing this comparison and this one, and then what we need to, of course, what we need to find is how is arriving on these two. What I'm gonna do, guys, is I'm gonna give you 10 minutes, let's say, to solve it, and then we can go from there. And after, if you don't solve it on there, of course, I will show you how to solve it. And then after this warm up, we can start with the DragonCrack. That yeah, that should be also easy to do. Okay, guys. So if you have 10 minutes, please solve it. If you have questions, choose unmute yourself or drop it on the chat. All right, guys. So do you guys need more time? Because I see no one solved it yet, but we can go directly with explanation. Does anyone has any questions? All right, then we go ahead with the explanation of it. So, well, basically, as you can see, so we are here, and I already marked it here. So basically, what it's doing is, well, let's go step by step. Stop this. So I just set up a brick, but let's put it at the start of this main. So we start off it, and then we're gonna reach the first print, the first called printf. Right after that, well, it's gonna call it a 3 printf again. This should have been solved with 1, but still it's been line by line. And then what it's doing is well, it's setting up the variables, right? One of the variables before asking you before the second print, as you can see, well, it's asking you for the print. One of the variables is gonna be set with this direct value, right? This value. This 1, 2, 3 to be 14H is the, well, it's the decimal representation of yeah. Let's check it out. So if we can copy this, and then we can open the, we can open here, and then it will decimal representation is 190.82004, or we can also do like because we have a Python console here, we can just do print, and then well, if you want to, we need to remove the X account, and we need to do it like this, and then we'll have the decimal representation. This, if we use that, of course, as a value of the scanf, as you can see, because, and how do we know that is the correct one? Is because in the comparison is using what is on EBP, and it's going to compare it with the values stored previously on bar4, right? So to enter, and then if we continue, we're going to see now it's going to compare the values of it, and then we're going to end up on the true one. Okay, did you guys follow along? Guys are quite shy today, but I hope you were able to follow along. Okay, so let's close this one. Yes, you want to continue? Yes, okay. So that's for the warm up. So we can tackle the other one. There is the DragonCrack. Should be here. Yes, we have it here. We can open it with the Visual Studio, so we can see the source code. Okay, as I mentioned before, on this one, on the DragonCrack, what happens is that we have several anti-reversing techniques. Well, the first one, well, let's open it, of course, in IDA or in China. Well, but we need to run it, so let's open it here. All right, so the first thing to do is to, well, to go into strings. We need to run it, of course, to understand what happens. So let's run it just like it is, and then we can see that it's doing some magic stuff there. Just I think it's well, basically pressing enter, and then you need to follow along the game, right? But you know, it's already starting here on press enter to continue. So based on this, we already know where do we want to start. We can start here. Like, shall I pick up character, race, and gender align for you? You can go there. I'm gonna stop it as it is right now there. Then we can try to look for strings that will correspond to that, and we can see that all the strings from the game itself, they are here. So we say that we wanted to go to the second one. So yes, that is, shall I pick a race, role, gender, and alignment for you? That's one, or we can go to the other one, of course. Then and then from here we will see that we have the references to this string, and if we click on this one and then press X, then we will see the references that are listed here. There's only one, and then we can go right to that one. Yeah, so we got here, and then, well, from there, if we set up a breakpoint, then we can choose go ahead and choose continue with it. And then on here we can also follow, because I have provided you guys with the source code. Where is this? Yeah, so the first thing that happens, this is the main function. So for the main function, what's going to happen is that first it's going to do this, and this is the reason. Well, let's maybe stop here. This is the reason why. There after the. So this is the reason why when you run it, you will see that it's pressing a lot of centers, and those are meant to to disrupt your disassembly, right? So you will see that it says, sorry, this node is too big to display, and this because it's actually too big to display. The function main is way too big to be shown here. So what happened is that the IDA fails to actually show you the representation, to disassemble it and show you the representation of it. Also, if we want to decompile it, it says decompilation failure to pick a function. And well, something you can do is to, well, of course, as I told you on the last one, you can choose going to the compiler itself, and then you need to make the max size bigger, so you will be able to do it. But also that will give you some issues because you will start consuming memory that you shouldn't consume. Well, that's another trouble. Okay, after it goes all the way, these thousands and thousands of enters. We are almost there. Yes. Well, then we will see that is also these strings that are set up, and that is just to just to trick you that these might be the serials. They are not. They are just strings with serials that looks like those, and then some what are you looking at, and we can see those also here. And IDA is smart enough to not join all the what are you looking at, actually, because they are all exactly the same. There's only one string, and it's making this guy. And if we if we make the reference, you will see that if you follow along that reference, it has a lot of references because of the amount of strings that are exactly the same. And for the serials, they are all different, of course. So they are all listed here separately. All right, so to follow along, you will see that, well, first is the intro of this game. And then, well, shall I pick a character, blah, blah, and then if you answer yes, then we'll continue. We'll call system CLS to clear the screen every now and then. And then after this one, it will call is the bagger present. How do can bypass is the bagger present? As you can, as you can see, is the bagger present is being called here. I will show you the representation of it in IDA as well. And well, actually you can see it here as well. So actually, let's move there. So it's here, and then so basically we at here, like live 50 secret key action right away, and then we have these calls to these two different subroutines, and then let's actually follow along and see what are those. Remember, we can do this like that. And for the next one, all right. And then it's gonna call easy bugger press, and we need to follow the shams as well there. And then it's gonna do this sham if not 0. Based on the results, as you can see here on the left side of the screen, it's gonna jump to clear the screen. Yeah. Or it's gonna, well, exit, of course. So you see, so basically if the bugger present, and basically the dragon is gonna cast is the bugger present. And as you remember, if we go to the anti-reversing reference, we can follow along for is bugger present. There are others. There are others anti-techniques implemented on this crack me, but we're gonna check on those later. So because this is the first one, and as I remember, I think we mentioned it last time. So basically, this is the kernel 32. Remember, it's coming from kernel 32. Kernel 32 function was introduced in Windows 95. Returns a non-zero value if the bug is present. The check can be made using this code. Blah blah blah. Identical to some editor. So basically, you can do it for 62 or 64 bits and something like this. Should do, and then internally the function simply returns the value of the flag being debugged. And the check can be made. This in 32 Toxamated 32 Windows or 62 versions. It's different. So basically, remember, it's coming from kernel 32, and how can we verify that? Well, first, let's remember here. How can we? I just put a breakpoint there. How can we verify that? We can just go into the imports, and then inside the imports, we will see that we have kernel 32 listed here as a library, and one of the libraries is the bugger present. Yeah, that's something you can check, and if it's calling it directly, it will list that here. If it's calling you, but you cannot call it by offset as well. And some clever things that you can do is to, well, first run this, and then what you can do is on the modules, you can navigate into that module. For instance, the kernel 32 in this case, no, for instance. Wait. Oh, I cannot go because it didn't stop. So go. Now we should. I don't know, for some reason it created a pseudo go. I think I pressed the wrong key, but okay. So kernel 32, as I said, now it is stopped. So kernel 32, go there, and then it will show me all the functions on kernel 32. And then if I go to easy bugger present, I can double click on it, and instead, well, I can follow the sham, or I can choose directly press F2, and what is going to happen is I'm setting a breakpoint right now, but as you can see, it's not on my binary, but this breakpoint is set on kernel 32 DLL. Yeah, so it's inside the DLL of kernel 32. Kernel 32, I have a breakpoint there. So every time easy bugger present is called, it will hit my breakpoint. So if I go back ESC and then go back into my code, I can even I can even list the breakpoints, and I can I have it here. Well, it says kernel 32 is bugger present, and I can remove all my breakpoints. So I can show you that if I run it like that, then as soon as is bugger present is hit, it will stop on my breakpoint. So we start there. Yes, Yes, continue, continue. Yes, and then as you can see, now it just hit my breakpoint inside kernel 32. So it's not the breakpoint on my code on the DragonCrack, but on the kernel 32. If we follow along, we can see that this is the kernel base is debugger present, and it's similar of what I show you. Yeah. Is similar of what I show you here, right? It's and then it will return that value, and the value should be, yeah, there. Okay, so right after that is gonna use this champ, and what something we can do here is to, well, you can change the champ, because as it is right now, what's gonna happen, as you can see, didn't follow the champ, and then it just called, well, I think it called exit. First is printing the method, and then he's gonna call exit and stop the execution, right? So what we need to do is to, well, patch that. And there are two ways to patch it. Continue, then again on the breakpoint. And then from here, what you can do is to say run until a return. So basically, it will continue the execution until we return to our code. Boom, there you go. So what we're gonna do now, let's list the breakpoint and remove that one, remove that breakpoint inside is the debugger present. And what we can do here, because well, first let me show you how what we can do. So we are there, so we are here. That's where the instruction pointer is, and then we go there, and then we're gonna change. It says champ if 0, and it's not 0. So we're gonna change it. Double click on it, and then now it's 0. So if 0 is and now it's not, and then it champ. You see, I continue with the fate, and then it goes there, and then we hit the dragon instead of the dragon hit us. We continue until there, and we'll see. You hit the dragon with all your strength, and he falls, dropping a key, but before dying, he hit you for the last time. Or next to you, a small glowing box appears. Okay, but the problem here is that, okay, we choose champ if the debugger present over it, but the problem is that every time we need to wait for that, and we don't like it. We don't like to wait like that, and also we need to, every time we hit this with this breakpoint, we need to champ it manually, right? Because as it is right now, that's not going to happen, right? So I need to do it manually. So how can we do this automatically? We need to set a conditional breakpoint. So for that, we edit this breakpoint, and then, using IDC, that is the scripting language of IDA, we can set value. And how can we get more information about it? X-ray support. Oh no, this is not the one I wanted to show you. Did they change the? This is for get value, but I want to show you the documentation of IDA. IDA IDC IDA set well, this documentation of it, I cannot find it. They might have just changed it, but you can get the IDA docs. I don't know why it's showing like that. There is a better idea though. Let me see. Oh, you know why? Find it because I think it's because I am Bing for some reason. IDC set value. Yes, that's the one. Okay. So here you have all the functions that we wanted to use this particular one. So basically, it's the same as was showing you before, but on the other screen you was showing this, and I want to show you that there is this document that you can use, IDC module, and you only have everything, not only that one, because you mostly don't want to only use this guy, right? You want to use the whole thing. Okay, subtract value, what we need is the register name that is going to be set here at second value of the argument of this function, and then the value, the new register value, of course. So on our case is 1, right? So we need to say 1, and then the register, the flag, like that. And then, well, we can break at the beginning, and then we can continue. Let's see if it works. Okay, boom, and then we jump it and it hits our breakpoint, but after hitting a breakpoint, it continues. But now something that we can say is, hey, is that good enough? Because now every time I need to continue the execution with it, and if I have like thousands of breakpoints, that's not something useful. Then what we should do is to right click on it again, edit, and remove the break. So it's a breakpoint that is not gonna break. So well, we can trace it, or but it's actually not needed. All right, so we can not break. So that's weird to say, because on our breakpoint now it's a conditional breakpoint that is going to set 1 on the flag set F to avoid the is-bagger present anti-debugging technique, and it's not going to break. So, but how can I show you that it did break indeed? Let's use another breakpoint for that. So it's not going to break on this one, but it's going to break on this one. So it's going to stop here, and this one is going to go over it, but it's going to set the condition. All right, if that's true, then it should stop on the second one. All right, go, yes, continue, that, and then we are here. You see, instruction pointer. Yeah, it worked. Okay, so what happened now? Well, we can grab the key as it is right now. What in order to win this game, we need the key. Of course, we need to grab the key. We need the key, and we need to have more than 0 life, right? So if we die on the game, then we cannot. We cannot win the game if we die. And we also need the secret key. As it is right now, we are grabbing that key. Continue, and then it comes the second detection. I was gonna say, okay, the dragon has used magic upon you. Okay, and stop the execution. So if you were follow along, you were you should have been able to see what happened right there. It's right now it's not is-bagger present, but it's the second type of protection. That is, we can go ahead and remove this one and just go into this one. So also we can do something clever like this one, and we can rename this subroutine. That is this whole box. We can choose click N, and then we can call it is debugger present spell 1. That is the spell call from the dragon, right? So we say yes, and then we change it. Oh, I changed the wrong one. Anyway, no. No worries. I think you understand what I'm trying to do. And then the second one is going to be this. That is actually the BM detection. Let's do it again so it makes more sense. BM detection. Boom. Okay. So it's going to do this, and then it's going to jump here, and it's going to call BM detection. If we go back to the source code, we can see here that basically we did this, right? And then we grab the key. When we grab the key, it's going to say if inside VMware or VPC, that is a virtual box, virtual PC, sorry, then you are dead with VM detection. And also inside, after that, it's going to check for the backup present, and it's going to check if there is a hardware breakpoint. Hardware breakpoints are another type of breakpoints, and you can set it up here at the breakpoint, and you can set, okay, no, not software breakpoint, but also hardware. And hardware breakpoints are stronger than software breakpoint, but you cannot set an infinity amount like a software breakpoint. It's like interruption that you can use directly from your virtual CPU. All right. Yeah, so we need to bypass this. So what we want to do is to bypass all the way this. So if we ended up here, and then sham if not 0, and then we can set 1, and then again. And then we continue, and as you can see, we choose we continue with the game. That's it. But again, it's gonna call is a backup present spell. You see, and because we bypassed it, should be showing there, and now it's gonna ask us for the key, and we need to type the key. Basically, we need to get the key. And what's the key? Well, let me says you're about to use your key to escape the dungeon. So we are here right now, right? So then it's gonna ask for the key, string secret key, and then it's gonna choose create this variable and secret key, and then it's gonna compare. It's gonna compare the key. Okay, so let's type random key. And then we haven't defeated the dragon in this case, because it says your key has magic. And then, yeah, there you go. And we can see it here. Well, we can continue with execution so we can see. And all right, guys. So what I'm gonna do now, we are on the last part of it. So if you follow along, so basically what we are here right now. So you know how to get here. I'm gonna give you 5-10 minutes, and then you should be able to solve it, and then you can tell me your key on the key that you need to use on the chat. If you have questions or you are stuck again, please type it on the chat or you mute yourself and tell me. All right, guys. So you are following along. You will see that the key is actually always in your computer. It's not something you need to discover, but it's something that is on your computer. And you can tell that if you get the dragon key, right? The dragon key is is created here, and then so this, does anyone have it yet? Yeah, that was enough of a clue. Okay, let me show you here. Basically the secret key is gonna be your computer name. So if you do this, on my case, it's gonna be this guy. So, and if we run it again, let's go to it. Oh yeah, of course we need to. We haven't made the auto recognition of big points. Okay. Let's go there. Go. We'll use a key. And then we type our secret key. And there you go. So it's like those games where you have to look yourself into the mirror, and then you can tell that it was always in you, the password. It was always the name of your computer. Okay, guys, I hope you enjoyed this training. I will share the recording with you guys later on, so you can follow. Yeah, you can do it on your own pace. And well, next month we're gonna do a similar training, but it's gonna be related to exploit development. We're gonna what the plan is to do some basic overflows, and then move all the way into return-oriented programming. Of course, the piece is going to be quite quick because we need to cover a lot of ground there. But there is a lot of information in the Exploit Pack website and some trainings that you can do, so you can shape up. Before the training, you have a month in advance. And if you have any questions or any concerns or feedback that you want to give us regarding these trainings, yeah, feel free to drop me a message. Okay, guys, thanks. Well, see you around. Bye, guys.